Hello and welcome to my science tutorials. In today's video, we are going to be looking at mole concept 2, where we will dive into what? Concentration. Before we begin, if you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. What is a solution? A solution is a homogeneous mixture of a solute and a solvent. A solute is a substance that is soluble in a solvent, and a solvent is that substance that dissolves the solute and it is usually a liquid. Now, the quantity of solute in a unit quantity of solution is called the concentration of the solute. Concentration can be expressed in four main ways. We have I, the amount concentration, which we normally just call concentration. II. We have the mass concentration, III. We have the molar concentration, and then lastly, we have the mole fraction. Now, for the purpose of these tutorials, we are going to be looking at just amount concentration and mass concentration. So let's begin. What is amount concentration? Amount concentration, this is the amount of substance dissolved in 1 dm cube on 1 liter of a solution. It has the SI unit of what? Mole per dm cube. Mole per dm cube, or mole per liter, or molar. Remember, I said amount concentration is the amount of substance dissolved in what? 1 dm cube, or what? 1 liter of solution. Now, amount concentration is given to us by capital C is equal to what? N over what? V, where N is what? The mole. V is the volume. This is where we get the definition what? Amount concentration is the amount of substance dissolved, which is what? The mole. The mole here is the amount of substance dissolved in 1 liter of a solution, and then the liter of solution is the volume. All right. Now from here, we know mole can be written as what? Mass over molar mass. So if we substitute this into this as our equation 1, we get our concentration to be what? Or amount concentration to be mass over molar mass multiplied by volume. So this is very important in calculating concentration. Let's go ahead. What is mass concentration? Mass concentration, II, mass concentration. Mass concentration, this is the mass of a substance dissolved in 1 dm cube of a solution. It has the unit gram per dm cube or gram per liter. Now, mass concentration is given to us by the symbol ρ is equal to mass of a substance dissolved in what? A volume of solution. Now, from here, we know that what? From here, we know mole is mass over molar mass. So from here, if we make mass the subject, we get our mass, to be what? Mole multiplied by molar mass. Let's make this equation 4, because this is equation 3. Now, if we substitute equation 4 into this, or in place of this, we get what? Mass concentration to be what? Mole times molar mass divided by volume. Now, we know mole over volume. What we have over here, let me use another color. Mole over volume is what we have as what? The normal concentration. So it implies that our mass concentration is equal to what? The amount concentration times molar mass, equation 5. So these equations that we've seen so far are very, very important in calculating or solving problems involving concentration. First of all, we say what? Concentration is what? Mole over volume, or concentration is what? Mass over molar mass multiplied by volume. We also said mass concentration is what? Mass over volume, or mass concentration is equal to what? Amount concentration times or multiplied by molar mass. We also know that mole is what? Mass over molar mass. Alright, with these few formulas or deductions that we have so far, let's go ahead and solve some questions. Example number 1. Calculate I, the concentration of solution prepared by dissolving 5 grams of sodium chloride to make 500 cm³ of solution. II, the amount of sodium hydroxide in 1 dm³ of a solution of concentration 0.1 mole per dm³, given that the relative atomic mass of sodium is 23, chlorine is 35.5, oxygen is 16, and hydrogen is 1. So let's write our solution. So I, the concentration of solution prepared by dissolving 5 grams. So our mass is what? 5 grams of what? Sodium chloride. Okay, so we have our volume to be what? 500 cm³, which when we convert into dm³ will be what? 0.5 dm³, because 1000 cm³ makes 1 dm³. Alright, so we need what? We need the molar mass of the sodium chloride that we have. So the molar mass of sodium chloride is what? Sodium plus what? Chlorine, which is what? 23 plus 35.5. And this is equivalent to 58.5 gram per mole. Now that we have our mass, volume, and then molar mass, we can calculate our concentration, which is what? Mass over molar mass multiplied by volume. And this is equal to our mass is 5 grams divided by our molar mass is 58.5 multiplied by the volume, which is 0.5. So this is equal to 0.171 mole per dm³. So our concentration for the I is 0.171 mole per dm³. Let's have a look at the second aspect. The amount of sodium hydroxide in 1 dm³. So our volume is what? 1 dm³ of solution of concentration. So our concentration is 0.1 mole per dm³. Alright, and we have to calculate the amount of sodium hydroxide. Amount of sodium hydroxide means we need to find a mole or N. But we know concentration is mole over volume. Now that we have the concentration, we have the volume. Our mole is simply the concentration multiplied by the volume. So our mole is equal to 0.1 multiplied by the volume, which is 1. So the mole in this example is 0.1 mole. Alright, let's have a look at another example. I, what volume of 0.30 molar sulfuric acid or H2SO4 would contain 1.35 grams of sulfuric acid? II, an amount of 0.25 grams of aspirin with the formula C9H8O4 is contained in 100 cm³ of a solution. How many moles and how many molecules of aspirin are in 1 dm³ of the solution, given that the relative atomic mass of hydrogen is 1, carbon is 12, sulfur is 32, oxygen is 13, and then Avogadro's number is 6.023 multiplied by 10 raised to the power 23. So let's write our solution. I. What volume of 0.30 molar? So our concentration is 0.30 molar. Would contain a mass of what? 1.35 grams. And then the volume is what we don't know. So we need to get the molar mass of what? H2SO4. And this is equal to hydrogen twice hydrogen plus sulfur S plus 4 times oxygen. This is 2 into bracket 1 plus 32 plus 4 into bracket 16. The sum of all these numbers is equal to 98 gram per mole. Okay, now we need to find the volume, and we know concentration is equal to mass over molar mass multiplied by volume. So if we make volume the subject, we are going to get, we cross multiply, we have concentration multiplied by molar mass multiplied by volume is equal to mass. So we divide by what? Concentration and molar mass. Concentration and molar mass. So we get our volume to be mass divided by concentration multiplied by what? The molar mass. So our volume is the mass, which is what? 1.35 grams divided by the concentration, which is 0.30 multiplied by what? The molar mass, which is what? 98. So our volume in this example is 0.046 what? dm cube, which is equivalent to what? 46 cm cube. All right, let's look at the II aspect of this example. II, an amount of what? 0.25 grams. So our mass is what? 0.25 grams of aspirin. So the molar mass of aspirin, C9H8O4, is this 8 multiplied by hydrogen and then 4 multiplied by oxygen. This is 9 into bracket 12 plus 8 into bracket 1 plus 4 into bracket 16. This is equal to 180 gram per mole. So it contained what? 100 cm cube of solution. So our volume is what? 100 cm cube, which is equivalent to what? 0.1 dm cube. So we are being told to find the how many moles and how many molecules of aspirin are in 1 dm cube of solution. All right, so first things first. So first of all, we need to get the mole of the aspirin that is present in what? 100 cm cube. So we can get that by using the formula mole is equal to mass over molar mass. So which means our mole is equal to 0.25 divided by 180, and this is equal to 0.001389 moles. All right, now that we have the moles, let's go ahead and see what the second aspect of the question is telling us to find. How many moles and how many molecules of aspirin are there in what? 1 dm cube. So our volume is what? 1 dm cube of the solution. Now if We already find the mole in what 100 cm cube, and it's equivalent to what this what we have over here. So if the mole in what 0.1 dm cube, okay, is equivalent to what 0.001389, then the mole in 1 dm cube will be equivalent to what? Let's use the symbol n. So if we cross multiply, we have 0.1 n is equivalent to what? 0.001389. So our mole will be what? 0.001389 divided by 0.1, and this is equal to 0.01389 moles. Alright, so it means the mole in 1 dm cube we now have, and then we have the volume, so we can now go ahead and calculate the second aspect, that is what? How many molecules of aspirin that we have. Now, how many means the number, so the number, which is capital N, is equal to what? The mole multiplied by what? The Avogadro's number. So the capital N is equal to 0.01389 multiplied by what? 6.023 times 10 raised to the power 23. So our capital N, or what? The molecules of aspirin present in this example is 8.37 times 10 raised to the power 21 molecules of aspirin. So thank you so much for watching. If you are new around here, kindly consider subscribing so that you don't miss any of our latest tutorials. Thanks for watching once again, and I'll see you in the next video. Bye bye.